Today I'll be explaining the topic vibrational partition function. The partition function gives us the number of energy states which are accessible to a molecule at a given temperature. Now we obtain the partition function from the Boltzmann distribution law, which gives us this formula, and by substituting these constants we are able to rewrite this equation in a form which is dependent on energy and temperature. Now, taking the summation of all microstates, we get this form of the equation where the summation portion is the partition function Zi. Now, for the case of vibrational energy states, we rewrite the partition function as such. And now when we studied spectroscopy, we were able to obtain the vibrational energy eigenvalues for the quantum harmonic oscillator by solving the Schrödinger equation, and we obtained this equation. The vibrational motion of a diatomic molecule is the same as that of the quantum harmonic oscillator, and in this case the degeneracy is also reduced to 1. So when we substitute these values into the equation for the vibrational partition function, we are able to obtain this equation. Now we take out the constant portion of the exponential part and we expand the series portion via binomial expansion. Here I have simplified the binomial expansion to a reciprocal of 1 minus e raised to minus h nu by kt, and by substituting that we get that the Z vibrational is equivalent to this. If you notice the numerator portion of this equation, there is an h nu by 2 term of energy, which corresponds to 0 point energy of the harmonic oscillator, and it is considered negligible. So the numerator tends to 1. So this is the final equation for the vibrational partition function. Next, let's study the graph between Z vibrational and temperature. At 0 Kelvin, the exponential portion tends to 0. So the Z vibrational tends to 1. So the graph initially starts from 1. At lower temperatures, where Kt is less than h nu, Z vibrational tends to an exponential factor. So the graph is exponentially increasing. At higher temperatures, the exponential term can be expanded binomially. So the Z vibrational tends to this, and we can simplify it such that Z vibrational is directly proportional to temperature. So the graph becomes straight at higher temperatures.